Just making this video for you. We have already talked about this, but I wanted to kind of go over it for you so that you get an idea of just what's expected with the addition rule, the OR probabilities, and you guys can follow along with the notes. This is 9.3, the addition rule, and so I'll just go through it here. First off, it says write all answers as a decimal, a percent, and a fraction. And it asks, what are the chances of rolling a fair six-sided die and getting a 5? The fair means it's not weighted. You have the numbers 1, 2, 3, 4, 5, 6. If you had 3 on every side, 3, 6 times, that would not be fair. You could not roll a 5 that way. So you have numbers 1 through 6. It's not weighted so that it falls a certain way. And what are the chances of since your sample space is the numbers 1, 2, 3, 4, 5, and 6, and only one of those is a 5, then you have the probability of 1 out of 6. Now, if you put that in your calculator or you do that division by hand, then you'll see, let's see if I pull my calculator up here. If I take 1 divide by 6, and I realize you can't see that screen all the way, but if I take 1 divide by 6, it gives me 0.166666667. So as a decimal, that's 0.17. 0.166. I look at this 6. I'm going to round to that place value, but I look right next to it at that 6. If it's 5, 6, 7, 8, or 9, it rounds up, so this is 0.17. And then, technically speaking, then this should not be, let's see here. This should not be exactly equal. It's not equal. It is approximately 0.17. So this is one of my answers. There is my fraction. So there's my fraction. There's the decimal as a percent. 0.16666, and this just repeats. If I multiply that by 100, it moves the decimal place over 2 places, 1, 2 places. So this is then 16.6666, and that rounds then to 16.67%. Make sure that you're writing percent when it talks about percentages. Then it says, state whether these events are mutually exclusive or not. Remember that mutually exclusive is when you have, and I think that it talks about that in, I don't know if I have the vocabulary here. Let's see. Oh, here it is. Yeah, so mutually exclusive events, and you have this in your vocabulary here as well. It says mutually exclusive events that cannot occur at the same time. If the probability of A and B is 0, then they're mutually exclusive. What's the example? For example, drawing a red card and drawing a black card from a standard deck of cards. It's either red or it's black. It cannot be both. Drawing the name of a student from our class that was born in December and also born in January. Not possible. You're either born in December or you're born in January. Can't. It has to be one or the other. Okay, so those are mutually exclusive. If there's something that they have in common, if there's a probability other than 0, then they would not be mutually exclusive. So let's go back. All right, driving east and driving west. I'm going to put ME for mutually exclusive, or this symbol, which means not ME for not mutually exclusive. Okay, so driving east and driving west, no, those are mutually exclusive. You can't drive east and drive west at the same time. Sleeping and breathing, this would be not mutually exclusive. Yeah, because if you're sleeping, then you're breathing. If you're not necessarily because you're breathing, you're sleeping, but yeah, if you're only sleeping, you need to still be breathing. Drawing a red card and a queen from a regular deck of cards. It could be a queen of hearts or a queen of diamonds. Both of those are red. Oops. Both of those are red. And so yeah, these would be also then not mutually exclusive because they can be both at the same time. You can draw a queen, you can draw that's red, you can draw a queen that's red, two queens that are red. If it's a queen of clubs or a queen of spades, excuse me, queen of clubs, that's black, or a queen of spades, both of those are black, but the queen of diamonds the queen of hearts and the queen of diamonds, both of those are red. All right, waking up late and getting to class on time. Could you do both of those things? Sure. Yeah, you could wake up late and still get to class on time. That's possible. You just have to, instead of having a 5-course breakfast, you'll only just grab a donut and go, or just don't eat breakfast at all, or get ready in 20 minutes rather than your regular 3 hours. You could still get up late and still get to class on time. That's a possibility. So this would also then be not mutually exclusive. All right, let's go over here. It says you have a bag of 20 marbles, 7 are yellow, 5 are blue, and the rest are red. How many are red? Let's see. 7 plus 5 is 12. That means here, that's 8 marbles. 7 plus 5 plus 8, if I'm not mistaken, that's 20. So yeah, 8 would be red, 5, 5 is blue, and 7 are yellow. So what's the probability of drawing a red marble? Well, 8 out of 20, and both of those are divisible by 4, or if you just plug that into your calculator, remember you can do math, push the math button, and then enter again, enter twice, enter, then that'll give it back to you, in this case, as I think 2/5 there. 4 goes into 8 2 times, and 4 goes into 20 5 times, so 2/5. Make sure that you're writing your fraction in simplified form. This is exactly equal to 0.4, which we can just add a 0, and then it's out to 2 decimal places, so there's 0.40. Or this is exactly equal to 40%, and I could write 2 zeros just to show I can take that to the hundreds place. So that's 40%. And that's it. Probability of red, 40%. What's the probability of blue or yellow? Now, you can really just count if you want. You could just say, well, there's blue, that's 5, and there's yellow, that's 7, so it's 12 out of 20. You can do that. The formula for calculating OR probabilities is this. The probability of A or B is the probability of A plus the probability of B minus the probability of both. And the probability of, blue would be 5 out of the 20, plus the probability of yellow would be 7 out of the 20, minus the probability of both. You can't draw a marble and have it be both blue and yellow. So this would be 0 out of 20. And then that would be 12 out of 20. And so 12 out of 20, both of those are divisible by also by 4. So that's 12 out of 20. 4 goes into 12 3 times, and 4 goes into 25 times. So that's 3/5. That is exactly 0.7. 0.6, which is 0.60 as a decimal, and then that's exactly equal to 60%. All right, red or blue? What's the probability of red or blue? Well, let's see again. I'm going to cross those out. Red, 7. Red is 8. The probability of red is 8 out of 20. Plus the probability of blue, red or blue. Blue is 5 out of 20. Again, 0 out of 20 for both. Can't be both. So 8 out of 20 plus 5 out of 20, that's 13 out of 20. And they don't have anything in common because 13 is prime and 20 is not a multiple of 13. So 13 out of 20 is my simplified fraction. If I bring my calculator up and I put 13 divided by 20, I get 0.65. And then again, if I hit math, enter, it gives me back the same fraction. So 13, if it gives you the same fraction, that just means you could not simplify it. So that's 13 out of 20. That's exactly equal to 0.65, which is exactly equal to 65%. Which, again, I could write that with 65. I could write it as 65.00%. Either way. But this just shows I'm taking it out to the hundredths place. But it doesn't add anything to the overall value of that number. All right. This one is kind of like, all right, they give me the probability of A, they give me the probability of B, and they've also given me the probability of A and B. So in this case, it's, just straight up, that's what you do. You plug it into the formula. So the probability of A, 0.37, plus the probability of B, 0.45, minus the probability of both, and that's 0.17. 0.17. And then I can just plug those values in. 0.35. Oops, sorry. This is 0.337 plus 0.45 minus 0.17. And then hit enter, and that's 0.65. So here, all of these numbers apply here also. The same. So 0.65, that's a simplified fraction, that'd be 13/20, 65%, et cetera, et cetera, et cetera. If I wanted to, I could go back to that again, hit math, enter, and again, that gives me back, even though I use the decimals to get that number, these decimals here, 0.37, 0.45, minus 0.17, came out to 0.65, but when I converted it, math, enter, it gave me that fraction back, 13/20. So the same values there would apply. Now here, what's the probability of A union B? Remember that A union B can be also said, what's the probability of A or B? It means the same thing. 4/7 plus the probability of B, 10/21 minus the probability of A and B, that's the intersection is and, minus 4/21. And you're like, oh no, fractions. I can convert this one into the 21st by just multiplying both the top and the bottom by 3. Or, and I'm fine with this, you can just go to the calculator and plug it in. What happens is I'm going to show you both ways. Like if I take 4/7, 4/7 times 3/3, because that's 1. This right here, highlighted in blue, 3/3, that's 3 divided by 3, that's 1. I'm multiplying 4/7 times 1. I'm not changing its value, just changing how it looks. So 4 times 3 is 12. This is 4 times 3, and that's 12. 7 times 3 is 21. So I've got 12 over 21 plus 10 over 21 minus 4 over 21. 12 plus 10 is 22 over 21 minus 4 over 21, and that would give me 18 over 21. Both 18 and 21 are multiples of 3, so I divide 18 by 3, I get 6. Divide by 3, divide by 3. So this would give me 6, this would give me 7, so 6/7. Now, I told you we to do this in the calculator also. So if I take 4/7, 4 divided by 7, and I add 10 divided by 21, and then subtract 4 divided by 21, I get that decimal. But if I hit math, enter, enter, that gives me back 6/7. So I'm going to erase that just so I can write down my answer. But the answer here is 6/7, which is approximately equal to 0.8. The 5 next to it, that 7 makes it 86. 0.86 as a decimal, which as a percent is 85.6. 85.71. 85.71%. And those are your answers. All right, let's take a look at this this one down here. This error analysis, I'm going to leave that to you guys. Take a look at it. Remember, you can plug it into your calculator, see what you got. If you have any questions about that later on, you can ask me. The number of students in a high school is 2,400. That means this number, 2,400, has to represent everything in this box. All right. Of those students, 111 take Spanish. That number, 111 that take Spanish, has to be everything in this circle, including both of the parts. And this number right here, 800 take math, 2, that's everything here. And then it says, let's see here, 450 that take both Spanish and math too. That's where we're going to start. That's this space right here. So that's 450. I need to know what goes there. So I'm going to take the 1100 that take Spanish, and I'm going to subtract 450. And I'm going to take this 11 and make that 10, bring one over here, take one from there, make that 9, bring one over here. And so 10 minus 0. I didn't need it for that. Come on. That's 0. 0 minus 0 is 0. But 10 minus 5 is 5. And then 10 minus 4 is 6. Just to kind of double check that, if I add 400 and 600, that's 1,000. 50 plus 50 is 100, so 1,000 and 100. That's what we got. That's 1,100. All right, good. So, sorry. This number here then is 650. And together, that's 650. 650 plus the 450 is that 1,100. Okay? Then I've got 800 that take math too. I'm going to do the same thing again. 800 that take away the 450 that take both. 0 minus 0, 0. Make that 8, 7. So 10 minus 5 is 5. Change that to make it look more like a 0. And then 7 minus 4 is 3, so that's 350. This is 350. And altogether then, this is 1100 plus 350. 1100 plus 350. And then 1 plus 3 is 4, and then I got 1. Is 1,450. 1,450 is all of this. All of that. That's 1,450. But I still have 2,400 in the whole thing. So I'm going to take this 2,400 and subtract 1,450. 0 minus 0 is 0. I can't take 4 from 0, so I'm going to borrow that. Oops. Come on. All right, there we go. I'm going to borrow from this 4, making that 3. Take that 1. 10 minus 5 is 5. I can't take 4 from 3, so I'm going to borrow from there. Make that 1. Make this 13. 13 minus 4 is 9. So this is 950. This number right here is 950. And as a double check, I can take those 4 numbers. They should add to my total sample space, which is 2,400. So if I take... I just brought 6 so you can see what's going on the screen there. If I take 650, add 450, add 350, add 950, I should get 2,400. Good. And then it says, okay, fill in the Venn diagram, then find the probability that a student selected at random takes Spanish or Math 2. I'm going to clear out my colors there, and I'm going to use this color. Let's use blue. I like it. It's nice. So Spanish or Math 2. I could also write that as Spanish or Math. Instead of the union, I could also just write the word or. Spanish, that's S is Spanish, or M for Math. All right. What's that probability? Well, this is Spanish or Math 2 includes those that take only Spanish and not Math, those that take only Math but not Spanish, or the 450 that take both Spanish and Math. That's included in the union. So I add those together. 650 plus 450 plus 350. 650, 450, and 350. We're good. And that gives us 1,450. I think we may have already done that. So I've got 1,450 over the total sample space, 2,400. That's the probability that you've drawn somebody at random from that sample of 2,400 students that they're taking either Spanish or Math. So I take 1,450, I divide it by 2,400, and that gives me that decimal, which if I hit Math, not alpha, sorry. Try that again. Math, enter, enter, and it brings it back to 29/48. So this is equal to 29/48, which is then approximately equal to 0.60, 0.60, which is then approximately equal to 60.42%. And those would be your 3 answers. All right, guys. I know it's kind of long video, but it's shorter than if I were here listening. You were listening to me. That should help you to fill out your notes. If you were already finished the other day, fantastic. Make sure that you're caught up with everything. Today is the last day for you to turn in any homework from Unit 8. If you have Unit 8 homework, that's from last unit, you can put it in the baskets on that table in the back. You can still do test retakes up until next Friday, but only if you have the homework complete, and that deadline is today. That has not changed. So, if you have any questions, send me an email, ryan.wattups@jordandistrict.org. You have my email. It's right outside the door as well. You can also send me messages through Canvas. You can also just leave me a written message and leave it with the substitute, and he or she will give it to me tomorrow. Or she'll leave it with me, and I will get it when I come back to school. Thank you. You guys will stay on top of your work. The test is coming up soon. We'll be testing on this on Monday the 24th for B days. And yeah, just let me know if you have any questions, guys. Take care. We'll see you soon.